In this exercise, we will discuss chapter number 3, integration exercise 3.3, question number 13. And question we have integral of ax divided by a square minus x raised to power 4 dx. So see, so far whatever question we have solved, here was the square. If first is square, second is also a square, but in this case we have x4, so do not worry about it. I will try my best to make it very easy. So see, a is constant, we can take outside the integral sign. In the numerator we have only x there, in the denominator we have a square, and instead of this x raised to power 4, I can write down x square then whole square dx. Right, this exercise is based on the substitute method. So t is equal to x square. If I will say t square, which is equal to x4, which we will use here, so that is why I said t square is equal to x4, but t is equal to x square, then dt over dx is equal to 2x. If we will separate the variables, so it will be dt is equal to 2x dx. But see, in the question, in the numerator we have x dx. Here we have 2x dx. So this 2 is extra. We can take this 2 on the other side of the equation. So divided by 2, it will be dt over 2 is equal to x dx. Now x dx is equal to 1 over 2 dt. So instead of this x dx, we can write down 1 over 2 dt. In the denominator we have a square, so instead of this a square minus the value of t is x square, so t is equal to x square, but we have one more square, it will be like this. This again, this exercise is based on substitute method, otherwise we can finish our question here directly. I can write down the answer, which is equal to, okay, one more step, that a over 2, because this 2 is constant, I can write down like this, dt divided by a square minus t square. If it is not the substitute method, directly you can write down your answer, that a2 sine inverse variable divided by constant plus c. But here I am not going to write down the direct answer. We will take the substitute one more time, which is equal to a sine of theta. So dt over d theta is equal to a cos theta. Separate the variables, dt is equal to a cos theta d theta. So see, in dt, we have now dt in the numerator. Instead of this dt, we can write down a cos theta d theta. And then in the denominator, a square minus, this is t is equal to a sine theta. So I can write down a square sine square theta. I will put the values here in the next screen, which is equal to a over 2 will remains the same, a cos theta d theta, and then here is a square minus a square. Instead of t, we can write down the value sine square theta. So a over 2 a cos of theta d theta, a square we will take as a common, then we have here only 1 minus sine square theta. And you know that 1 minus sine square theta is equal to cos square theta. So you can write down a over 2 a cos of theta d theta divided by a square will here and cos square theta. You can write down here, therefore 1 minus sine square theta is equal to cos square theta. We have put the values. This 2 will cancel with this under root, this 2 will cross with this. So we have a over 2 integral of a cos theta d theta divided by a cos theta. So a will cross this with this and this, only we have left a over 2, which is constant 1 d theta. Now we will do the integration. 1 over 2 and 1 d theta is plus theta plus constant of integration. So the value of theta from here, see, t is equal to a sine theta. If I say we want only theta, so theta is equal to sine inverse t over a. So put the value of theta here, which is equal to a over 2 plus sine inverse t over a plus c, right? But our answer should be in the same variable, whatever we had in the beginning. So see this one, t is equal to x square, because here is the x square variable. We do not have the sine square or t. So here we have to put the value of t. This is t, which is equal to a over 2. We have substitute 2 times. That is why we will put the values 2 times here as well. Now this is the answer. And this is the important question. I can write down here. If I say important, it means you have to practice it. And one more thing, that you should know the formulas very well in order to do the integration. If it's still any point is not clear, without any hesitation, you can ask me. And thanks for watching. Please subscribe to my channel as well.